So sticking with our theme of direct substitution for evaluating limits, this even works when we talk about things like square roots or radicals. So if I said I wanted to find out what the limit was as x approaches 2 of the function y equals square root of x, in essence, it's a little bit like that power rule that we were just talking about. The limit in this case is going to be exactly the same as if we took the square root of the limit as x approaches 2 of x. Well, we know what we're going to get right here. We're going to get the square root of 2. And as long as we're over the set of real numbers, we might not be able to find this limit as x approaches negative 2, but over the set of real numbers, this limit is exactly equal to the square root of 2. How about our limit as x approaches 3 of x squared plus 7? Well, by our substitution rule, we're going to be taking the square root of 3 squared plus 7. We don't come to an undefined number here. We get the square root of 9 plus 7, which is the square root of 16. So our root is equal to 4. And so our limit as x approaches 3 of the square root of x squared plus 7 is 4. Let's try this one. The limit as x approaches negative 1 of the square root of 4x cubed plus 7. Oh, well, we better be careful right here. Let's see. Do we get a real number? Well, we're going to be taking 4 times negative 1 cubed by direct substitution plus 7. So in this case, our root comes out to be the square root of negative 4 plus 7. Negative 4 plus 7, which is that we're going to come out to have the square root of 3. So it is within the set of real numbers, even though it's not a nice rational number. Still works. Does this continue to work for everything? Well, let's try another right here. And even in rational functions, as long as we're within the defined domain of the function, no problem, right? Let's talk about this one. The limit is x squared as x approaches 1 of x squared plus x plus 2 divided by x plus 1. We can use that quotient rule and treat this as the limit as x approaches 1 of x squared plus x plus 2 divided by the limit as x approaches 1 of x plus 1. Well, we know exactly what's going to happen right here when we substitute these numbers in. We're going to have 1 squared plus 1 plus 2 divided by 1 plus 1. Well, we know how that one comes out. We're going to have 4 divided by 2, which is just to say that our limit is equal to 2 in this case. Does it work here? Well, I don't think we get a 0 in the denominator, so we're okay. The limit as x approaches 2 of x cubed minus 3 is the same thing as 2 squared minus 3 divided by 2 plus 2, which is to say 4 minus 3 is 1 divided by 4, so 1/4 in this case. What might have happened if we tried to find the limit as x approaches negative 2 in this case? Well, if we think about the situation, we're going to get a fraction in which we're going to get negative 2 squared minus 3, which is 1, but we're going to get 0 in the denominator. We're going to have to say that this limit does not exist, simply on the basis that, well, the limit goes to 0 in the denominator, and we can't have that, right? That's undefined. So we're going to say that this limit does not exist. How about this last one down here? Well, let's think about that one as we go into our next video.